Good evening, ladies and gentlemen, boys and girls. Hopefully you can hear me. It'll be blind luck if you can, because technical issues, as you've all come to expect from me. So while I check buttons and click things that I probably shouldn't be clicking, I will hand you over to Conspiracy Cat, who will introduce our two guests, one of whom I'm sure is familiar to you, and we shall get the show on the road.
Brilliant. Did I have my microphone muted then? Did anyone clock on that I accidentally left the watch page open? Did I spoil that intro with loads of music?
Don't think so. No more than I spoiled it.
Well, it's good to hear. I'm really looking forward to this for two reasons. One is because a couple of weeks ago we had the man who is down here, I think, on the screen. Leo Filius was on, and he did an absolutely amazing job. But unfortunately, the guy he was debating, I think he was it was about as useful as a wet shoelace, wasn't he? And I think he was a Poe. So we kind of got school. So we owe Leo Filius a proper debate tonight. And I think we've got one. The man next to him emailed to ask for a debate on abiogenesis. And I was this tempted to take the debate myself. But I don't really know enough about it. And I know that the man that we've got here will do that side proud. But I'm going to let them both introduce themselves. Tangelo, should we come to you just so you can introduce yourself first? Because you're the new face to the channel.
Sure. My name is Otangelo. I am Swiss Italian. I live in Brazil. I am a Christian evangelical, a Christian for 36 years. And I used to have conversations with atheists, with unbelievers in regards of origins in general, about philosophy, epistemology, astrophysics, abiogenesis, evolution, whatever has to do with origins. I have two channels on YouTube. One is the God Talk, where I have conversations with all kinds of people, with believers, unbelievers, about different topics in regards of God. And I have the second channel. The name is Intelligent Design Academy. And there I post videos which are about intelligent design. And I have also a virtual library. The name is Reason and Science, .catsport.com. Maybe you guys can put the link afterwards so people can access it. And there I post all kinds of stuff in regards of origins.
Brilliant. I've just put the link to the God Talk channel in the chat if anyone wants to click on that and check that out. And I'll as the night goes on, I'll make sure that I keep cycling those around, and we'll get them in the description of the debate. So anyone watching this afterwards, they should be down in the description. So thanks for that. Leo, we've seen you before, but how have you been keeping since the last traumatic debate?
Been doing pretty well. I've actually got some content, original content, I should say, up on my channel finally. So that's been fun. I have a lot more coming. It'd be nice if I had a newer laptop just so I had a better webcam, but you got to make do with what you have. And I'm sure that if and when I grow larger, I might start a Patreon and then use some of that funds to purchase better equipment like most YouTubers do. So on my channel, I do science education and science communication, mainly from a secular point of view, a little bit of atheism, activism. I focus mainly on astrophysics, cosmology, and quantum mechanics, more of the advanced areas of those places where people tend to have misconceptions. Gonna do a little bit of politics as well, left-leaning politics. So if any of that interests you, be sure to subscribe. I'd be very much grateful.
Yeah, well, I am subscribed for one. Are you subscribed, Creaky?
I'm not, no, to be honest. Purely because I always forget to do everything that anybody ever asks me to do. Just ask Mrs. Blinder, she'll confirm that.
I should also mention that you can find me on Twitter at Leo Filius.
I follow him on Twitter.
The same way for my channel.
I follow you on Twitter.
There we go. And as the debate goes on, I'll keep putting all those links in the chat. I am really looking forward to this. Like I said, mainly because I was tempted to take this debate for myself, but abiogenesis, is not something I know a great deal about. So I'm looking forward to listening to both sides and learning. We decided who did we decide Creaky was going first off camera? I can't remember.
I did want to mention that if you have a link to my channel, I recently got my own custom URL. So if you want, you can just put youtube.com/C/Leo Filius, and that should link it straight to my channel.
Right. Brilliant. Well, I'll get that as the debate's going on, I'll keep putting that through, and it'll also be in the description. So anyone who's watching this tomorrow or whatever, we'll find that in the description as well.
Sounds good.
Anything you want to say, Creaky, before we
I'm almost too scared to say anything, but I will. Let me just address the side chat. I don't know who saw yesterday's video, but I was not saying that evolution created life. I am well aware that abiogenesis created life. I was merely pointing out it was about evolution. So for all of you who think I don't realize that abiogenesis created life, I do. And thanks for nobody noticing my sexy, manly new facial hair.
Right. This time next week, I'm going to copy it. This time next week, I will be...
I'm having my throat tattooed on Friday, so I had to get rid of the beard, and I didn't want to get it all gone, so I just took a chunk out of the middle.
It's good. No, this time next week, I will have the same thing. Okay?
Top man.
Say this time next week. If I'm honest, it'll take me about 6 years.
We can be the mutton chop channel. We can be the mutton chop channel. Anyway.
Oh, brilliant.
Not if I'm on. I can't. I actually just shaved today. My facial hair doesn't fully grow in, so I keep it. I keep it shaved, at least until I might be able to get something, a goatee going.
Yeah.
Not yet, anyway.
I thought for a second then you were going to say you keep it like in a jar or something. you just keep it.
Yeah, I feed all the hair to the monster I have in my basement.
Well, is that a euphemism? Anyway, let's crack on.
Oh dear.
You get to go first. I'm not going to put a clock on because I know you've been on before, but around about 8 minutes. If we start getting to the half-hour mark, I might have to call it a day. But around about 8 minutes. Take it away, sir.
So we are having a discussion on abiogenesis versus intelligent design. So for those who might not know, abiogenesis is not yet a theoretical framework. It is still a hypothetical framework. It isn't really one thing. It's a set of different things that we are slowly developing to help us explain how life may have arisen on the prebiotic or the early Earth when it was in a state where there obviously was not any life on it prebiotic. So over the last 100 years, we have come very, very, very far in figuring out potential pathways for how life may have developed on Earth. One of those was done in actually 1961, I believe, by Jean Oro. I think it was A.P. Kimball was the other person he worked with. And what he did was in a mixture of ammonia, hydrogen cyanide, and water, he was actually capable of producing a nucleotide base called adenine. And this was actually an important step. I believe that other nucleotide bases, nucleotides being the compounds that make up RNA and DNA, the development of these was pivotal because it showed that, hey, in conditions that would have likely been present on the early Earth, we are actually capable of making at least the bases that form things like RNA and DNA, which are very, very fundamental to all forms of life. A couple other people, Jeffrey Bada and Jim Cleaves, namely, who work at the Scripps Institution of Oceanography at the University of California at San Diego, did some experiments that were similar to those that were like the Miller-Urey experiment that was similar to those. But one thing that Jeffrey Bada was capable of noting was that in experiments that are similar to that, when they develop amino acids, these compounds that are called nitrites, which are developed by carbon dioxide and nitrogen, actually destroy amino acids, and it destroys amino acids nearly as fast as they form. And we do know that the prebiotic Earth, the atmosphere of the prebiotic Earth, would have had a lot of nitrogen and a lot of carbon dioxide in it. So this seemed to be somewhat of a problem for the development of amino acids, which are the basis for proteins. However, they did the experiment, and this time they added iron and other carbonate minerals to the mix and found that in this instance, these products were rich with amino acids, which suggested that on the early Earth, where we know that iron and other carbonate minerals were present, that they would have actually protected the amino acids from these nitrites, allowing the amino acids to actually be produced and be stabilized. So that was important because it showed that, hey, yeah, the early Earth atmosphere would have had carbon dioxide and nitrogen in it, and that does destroy amino acids. However, we also know that iron and many other carbonate minerals would have also been present on the early Earth, and those seem to protect amino acids from the process of being destroyed by nitrites. A very, very important study was done, I believe it was 2009, by Gerald Joyce, who is a renowned origins of life researcher, and Tracy Lincoln. And what they were capable of showing is that there's a particular RNA enzyme. They developed a particular RNA enzyme that was capable of catalyzing its own self-amplification through the utilization of chemicals called oligonucleotides, which are short strands, really short strands of nucleotides. And it utilizes these oligonucleotide substrates to essentially amplify or make further copies of itself. What these RNA enzymes can also do is they can cross-replicate with each other, catalyzing each other's amplification utilizing the same oligonucleotide substrates. This same study also showed that through genetic recombination occurring between the Watson-Crick pairs of these nucleotides and these RNA enzymes, that they can actually end up competing with each other, that better RNA enzymes can actually compete with other RNA enzymes for those oligonucleotide substrates that they utilize for cross-amplification or cross-replication, showing some sort of Darwinian selection here, which I thought was really, really important. And Gerald Joyce also did another paper, another work in 2019. I'm working a lot from memory here. I believe it was in 2019, but it might have been 2016. He was working with David Horning, I believe is the name, and they developed a polymerase ribozyme that was capable of synthesizing numerous complex RNA structures like aptamers, ribozymes, and even in low amounts tRNA or transfer RNA, which is what carries the amino acids to the ribosome so that they can be translated into or that they can be turned into a polypeptide chain to become a protein. And that this polymerase ribozyme can also replicate nucleic acids and amplify short RNA templates by 10,000-fold in what would be called an RNA catalyzed version of the PCR, or the polymerase chain reaction. Polymerase chain reaction, I believe that's what that stands for. I might be wrong there. So right. What they showed is that in the study, the two prerequisites for Darwinian life, the replication of genetic information and its conversion into functional molecules, can actually be accomplished with solely RNA in the complete absence of proteins. And you'll often hear from people who push intelligent design that you have to have proteins to do this. This study shows that no, actually, you don't necessarily need proteins to carry out these processes. There was another study done that was published in PNAS, Publications of the National Academies of Sciences, that showed that we actually have a viable pathway for how the first protocells could have developed. And what they were capable of showing is that cell-like membranes spontaneously assemble from simple prebiotic surfactants called fatty acids. I'm sure most people know what fatty acids are. But the thing is that these fatty acid membranes are unstable in solutions that contain salts that were very, very likely present on the prebiotic Earths or in the environments of the prebiotic Earth. However, what they found is that amino acids can actually stabilize these fatty acids against these salts. So in the presence of amino acids, these fatty acids would be stabilized. And because of this, what this means is that essentially you get what's called co-localization. Since they're stabilized, these amino acids, these fatty acids, can actually co-localize with other RNA enzymes, and you can get key components for what could have been the first cells. So we have viable pathways to how the first cells could have developed. There was another study that was done actually, I believe, August or September of this year, where they ran some computer simulations of potential pathways that could have been important to the development of life. And these pathways showed that, number one, the molecules that were created within these networks can themselves enable new types of prebiotic reactions, essentially stating that once you've started the process of developing more complex chemicals and chemical processes, that those more complex chemical processes might be able to catalyze even further complex chemical reactions. And you slowly get a chain reaction, a runaway chain reaction of increasing complexity from less complexity that existed before. Number two, that within just a few synthetic generations, simple chemical systems, including self-regenerating cycles, began to emerge out of these systems. And three, that the networks containing these prebiotic roots to surfactant species outlines a path to biological compartmentalization, which in turn can lead to the development of cells, which are very important for life. They also supported these simulations utilizing experimental results. So actual in the lab experimental results were capable of corroborating all three of these points that they were capable of showing through synthetic simulated networks. And for me, that this is really, really important because it shows all of this data is really, really important because while we haven't actually developed life in a lab, which I don't think that most intelligent design proponents would give as evidence that life can develop on its own, because they just argue, well, see, humans had to do this, therefore it requires intelligence. It's sort of like a win-win for intelligent design proponents, which I don't really see. To me, that runs along the lines of a conspiracy theory where any evidence against it can be turned into evidence for it by arguing that, see, there's obviously a cover up there. But all this data for me and for all of the researchers that I've spoken to at least shows that what we have here are viable pathways for how the earliest aspects of life and how potentially even protocells could have developed in the prebiotic conditions, in early Earth conditions. And one thing that I want to note, and I have actually asked people with PhDs in molecular biology, biochemistry.
Just one more minute, sorry, one more minute.
Okay, inorganic chemistry, evolutionary biology, all these things, that we will probably never have a set pathway for how life developed on the early Earth. At best, we will be able to develop numerous different environments and numerous different chemical reactions that could have occurred in these environments that could potentially lead to the development of life, but we will probably never be able to pin down exactly what those environments were and exactly what chemical reactions took place in those environments.
Ooh. There was a lot there. What do you think of that, Creaky?
I'm glad you went first.
That was good. My entire, I think, argument would have been the Muller-Urey experiment. So you brought about 55 more arguments than I would have done. So well done. Yeah, it's like I said, I'm looking forward to hearing a lot. Well done with that. Creaky, is there anything you want to say before we pass on to Angela?
Are we doing the poll tonight? Which I did send you a message, but
is that another innuendo? This is
yeah, no, not that poll. We'll keep that private like usual. Or are we just doing questions?
I'll put a poll up. I'll put a poll.
But I've got to open him. Sorry.
What is this poll that you guys are speaking of?
It's just very childish humor that probably only British people understand. It's a euphemism. So.
The other poll is the community. But what we do is we put a poll out on the community tab for people to say who they thought delivered the best opening statement, and then another one later on to say who they thought did the best debate, and essentially. But I'll get that done while Ortangelo takes center stage. So it's your turn, sir. Thank you for being patient with that. And off you go.
Yeah, Leo made 6 points. I took note of them, but since it was a bunch of issues all at once, I prefer to make my introduction. In our last debate, we were talking, my introduction was about the nucleobases, why they require the right isomerization, and that would belong to the RNA world. And this time I would address the metabolism first argument. And if you can put the PowerPoint presentation, so I will just read what I have prepared.
So do you need that on the screen? Sorry.
Yeah, sorry. I muted myself because I'm an idiot. Would you like to call out the slides by number or?
I will read. I will start with the second slide. I will read, and then I will ask you to go to the next one.
Okay. Yeah. Okay? There we are. So starting on slide 2. Yeah.
Yes, correct.
Okay. You do know that you will only be able to see the slides if you have the video itself open. It won't show up.
Yes, I have the power presentation.
Okay, brilliant.
On my screen, so I can read from there, and then I direct you to the next.
Okie dokie. So slide number 2 is on the screen now.
Is it on the screen so I can start?
Yes, you can. Yes.
Okay. Assumptions about the origin of life started with the idea that the environment where life arose was a complex solution of abiogenic organic molecules in the primitive ocean of some pool of hot water, including amino acids and sugars. In other words, all the necessary monomers for the synthesis of biopolymers. 3, please.
Okay.
Biological life is mainly composed of 4 building blocks of macromolecules: carbohydrates, lipids, proteins, and nucleic acids. 4.
Okay.
Carbon-based organic matter is a prerequisite of life and comes through the fixation of carbon dioxide in the atmosphere and represents the initial step towards metabolism. 5.
Okay.
In the naturalist hypothesis, organic compounds on primitive Earth would have been created in a reductive atmosphere from the action of sunlight and rays. 6, please.
Okay.
The atmosphere was claimed to be mainly anoxic, consisting of ammonia, methane, carbon dioxide, and water vapor. 7, please.
Okay.
The compounds would then have dissolved in the primitive ocean, concentrated and subjected to polymerization until they formed droplets of coacervates. The droplets supposedly grew by fusing with other droplets, were divided by the action of giant waves, and developed the ability to catalyze their own replication, which eventually led to the emergence of life. 8, please.
Okay.
In reality, things are far from that simple. The assimilation of carbon on the primitive Earth and the definitive origin of glucose, carbon-based sugars, is a major problem. To provide reliable explanations of how life came about, one of the crucial questions must be answered. Where did glucose come from on the prebiotic Earth? Without some means to create this sugar, limitations on the supply of food for metabolic processes would make the origin of life impossible. Sugars are, by far, the most attractive organic energy substrate of primitive anaerobic life because they are capable of providing all the energy and carbon necessary for the growth and maintenance of the first organism. 9, please.
Okay.
6 natural pathways for carbon dioxide fixation have been reported so far, each with its own biochemical reactions, requiring its own enzymes of a specific nature. Evidently, these cycles, all needing catalyst enzymes, were not present in the primitive Earth. 10, please.
Okay.
So the hypothesis is that a set of minerals capable of catalyzing each of the many steps in one of the cycles, the reverse citric acid cycle, was present somewhere on the primitive Earth. Another is that the cycle was mysteriously organized on a metal sulfide surface. The most serious challenge for proponents of metabolic cycles theories is the lack of specificity of most non-enzymatic catalysts. Theories of the origin of life based on metabolic cycles cannot be justified by the inadequacy of competing theories. They must stand on their own. 11, please.
Okay.
Regarding this hypothesis, Leslie Orgel gave a checkmate in the article, The Implausibility of the Metabolic Cycles in the Prebiotic Earth. He wrote, almost all hypothetical metabolic cycle proposals have recognized that each of the steps involved must occur quickly enough for the cycle to be useful in the time available for its operation. It is always assumed that this condition is met, but in no case have persuasive supporting arguments been put forward. Why should anyone believe that a set of minerals capable of catalyzing each of the many steps of the reverse citric acid cycle was present anywhere on the primitive Earth, or that the cycle was mysteriously organized on a metal sulfide surface? The lack of supporting evidence in chemistry is even more evident in proposals that metabolic cycles can evolve into lifelike complexity. The most serious challenge for proponents of metabolic cycle theories, the problems posed by the lack of specificity of the most non-enzymatic catalysts, in general has not been assessed. If so, it was ignored. Theories of the origin of life based on metabolic cycles cannot be justified by the inadequacy of competing theories. They must stand on their own. 12, please.
Okay.
But even if, suppose, somehow carbon fixation had started on the metal sulfide surface, there is an insurmountable gap in the type of prebiotic self-organization in carbon production and transition to the even simplest enzymatic carbon fixation pathway used in anaerobic bacterial systems. The reducing cycle of 3-carboxylic acid is considered the best candidate. This cycle requires 9 sophisticated enzymes, some with complex molybdenum cofactors, which also need to be synthesized in the production pathways of several sequential steps highly ordered by various enzymes. How could this transition have occurred without evolution? But let's explain better how this cycle works. And the best way to do that is to make an analogy. 13.
Okay.
Imagine a production line in a factory. Robots are aligned and the raw material is fed into the production line. The materials arrive at robot 1. It processes the first step. Then, when ready, the product goes ahead and is delivered to the next robot number 2, next processing step. And this procedure is repeated several times. In the end, there is a fully formed product, like a car door. This door is part of a larger object, such as a car. This door alone is useless unless it is mounted in the right place in the car model. Nobody would design a car door without previewing the superior purpose in the design and development phase, and based on the need, the complex shape of the door is specified that will fit exactly in the entire chassis of the car where it will be mounted. And the entire production line and each robot, the correct positioning and the sequence in which each robot will be placed must be planned and implemented as well. Everything must be designed with a higher end goal in mind. And there is an interdependence. If one of the robots stops working for some reason, all manufacturing ceases and the finished car cannot be completed. This means that a small incorrect connection of one of the robots on the door's production line can interrupt door production and the finished car cannot be produced. 14, please.
Okay.
Let's go back to the 3-carboxylic acid reduction cycle again. Here the situation is the same. We have 9 enzymes, molecular robots, where each one does the intermediate processing of the product until at the end, in the 9th enzyme, 2 carbons are available to the cell. The obvious question is, how could these 9 enzymes arise and have been grouped in the correct sequence to produce the final product so essential for life? First, that the amino acids which form the enzymes in this cycle use carbon, which they themselves help to manufacture. What makes the origin of these enzymes an egg or chicken problem is what came first. But secondly, let's even assume that this problem would have been solved. If only one of the enzymes is not present or in the wrong place, nothing is done. The cycle does not work. And an article published in the journal Nature in 2015 reported the reverse TCA cycle found in bacteria is catalyzed by enzymes with a high degree of substrate selectivity. The reaction substrates and the reaction sequence of the TCA reverse enzyme cycle are conserved. That means not evolved. So not good news for evolution proponents. 15, please.
Okay.
On the one hand, you have a system based on construction by means of an intelligent agent who routinely develops, plans, and designs automated machines and robots with future goals in mind. Machines that are made up of adjusted, functional, and strongly integrated parts of irreducible complexity. Functional systems rich in information, which have energy available and directed towards it, which routinely generate the type of phenomenon that is being observed. 16.
Okay.
And on the other hand, imagine a golfer who played a golf ball on a 9-hole course. Can you imagine that the ball could also play alone on the field in your absence? Of course, we could not rule out that natural forces such as wind, tornadoes, or rain or storms could produce the same result with enough time. The odds against this, however, are so immense that the suggestion implies that the non-living world had an innate desire to go through the 9-hole course. The same applies to the first reducing cycle of tricarboxylic acid. There is no reason to believe that enzymes would be formed prebiotically, and on top of that, they would enter a functional order and then start to fix carbon dioxide without direction. This is not an argument of disbelief, but a rational one based on the improbability to occur spontaneously. Okay, that's my introduction.
Ooh, right. Said I was not expecting to see the Krebs cycle in that. It's been a long time since I've seen anything like that. Technical stuff. Creaky, any thoughts?
Nope.
I'm interested to see where this is going to go in the back and forth. I've put
so am I actually.
Yeah, should be good. Should be good. I put the community poll up. What should we say, Creek? About 45 minutes, unless they decide that they've expanded, and then we'll go to questions from the chat.
Okay, cool. Yeah.
All right. How are we starting off?
Well, there were two things he mentioned. The Krebs cycle was one of them. I'll get to that. But the first one was the development of sugars. And I just did a quick Google search, and Albert Eschenmoser, who is now retired from Scripps Research Institute in California that I mentioned in my opener, in 2007, he proposed a different set of reactions that might potentially do this in a prebiotic world. And he started with glyoxylate, which is a 2-carbon molecule, and dihydrofumarate, I believe. DHF is how I might be pronouncing that wrong. DHF is what I'm going to call it. And Ram Krishnamurthy and some of his colleagues at the same Scripps Research Institute actually ran some studies to see whether this works. And they reacted the dilithium salt of DHF with glyoxylate, glycoaldehyde, glyceraldehyde, I think is the other one. And the glyceraldehyde one produced a mixture of 5 carbon sugars, xylulose and ribose, with a 60% yield. Now, I do want to mention that we haven't figured out how to actually develop DHF under prebiotic conditions, but the fact that this so smoothly and cleanly produced sugars is very, very promising. Also, in October, now about the Krebs cycle, so as it relates to that, we do have some viable pathways to how the sugars could have been developed. I don't think we need to assume that there's absolutely no way that nature could have done it, because let's be honest here, truth is stranger than fiction, and reality can do a lot of things that we can't, like make black holes, because we haven't been able to do that, or make galaxies, because we still can't make galaxies in the lab either. But in October 12th of this year, of 2020, a few people published in Nature Chemistry a potential pathway for a proto-metabolic process for the Krebs cycle. I would like to read here really quickly, if I may. Quote, furthermore, the alpha keto acid analogs provide a natural route for the synthesis of amino acids by transamination with glycine, paralleling the extant metabolic mechanisms and obviating the need for getting rid of the need of metal-catalyzed abiotic reductive aminations. This emerging sequence of prebiotic reactions could have set the stage for the advent of increasingly sophisticated pathways operating under catalytic control, end quote. So again, we see another viable pathway for how metabolic processes like the Krebs cycle could have been developed. And for anybody that's interested in that, I can cite the paper, but I can also cite from Quantum magazine, which is like a Scientific American or a Smithsonian magazine. They're a very, very well reputed scientific magazine that kind of parses out the complexities of that research in a way that might be more palatable for somebody who doesn't understand all of the technicalities of biochemistry. And I can link that in the comments after the debate if they'd like me to. But so for both of those, there are viable pathways to how these things could have developed. Just because we don't know everything or we don't know exactly how it happened doesn't mean that we aren't developing ways and aren't finding viable pathways for how it did.
Tangelo, take it away. What do you think about that?
Well, Leophilius, I think a major problem which is not being appreciated enough is that the trajectory to go from metal surface catalytic synthesis and reaction to have carbon prebiotically to the production by the reverse TCA cycle, that is an absolutely unsolved and huge gap, because you have there 9 enzymes which work very precisely in a very, very ordered process. And the make of each of these enzymes is an enormously complex process. And just to give you an example, for example, malate dehydrogenase, that is the first enzyme in that process. And it has, as a in its reaction center, it uses molybdenum. And there are many enzymes which are required for life to start, which use either molybdenum or other rare earth minerals, or in special iron and sulfur. Now, to get prebiotically iron and sulfur, that is a hugely complex process. For example, to have iron available for the cell, you need to chelate it. And for that, you need non-ribosomal polymer synthetases, which are literal production line machines which transform iron into chelated form into siderophores. And then there are import channels on the surface membrane. And these import channels of the membrane, they have a very specific amino acid sequence which recognize either molybdenum or iron or sulfur or other rare earth minerals. If that sequence is not correct, Leo, what happens? The cell is not able to make the importation of the mineral, and then it cannot produce the cofactors, the iron sulfur cofactors, or the cofactors with molybdenum, or what else. So this is already an irreducible complex system where all parts must be priced precisely in place. Otherwise, you have not granted the import of the materials, you cannot produce the cofactors, and you cannot produce the enzymes and proteins which are required in that cycle. That's why I always say that the cell is far, far more irreducibly complex than usually appreciated. Just that little tiny sequence of a few amino acids of that import protein on the surface, if it is not the correct amino acid sequence, you have no import of the minerals and you have no kickstart of life. That is a huge problem.
Before we continue, there's two points. So the paper I cited talks about the reverse Krebs cycle in the absence of metals or enzyme catalysts. To quote from them again, quote, "Here we show that the reaction of glyoxylate with pyruvate under mild aqueous conditions produces a series of alpha keto acid analogs of the reductive citric acid cycle without the need for metals or enzyme catalysts. The transformations proceed in the same sequence as the reverse Krebs cycle, resembling a proto-metabolic pathway with glyoxylate acting as both the carbon source and reducing agent," end quote. Secondly, the whole irreducibly complex doesn't work because that assumes that as we see things today is how they existed billions of years ago, which literally no biochemist is going to accept. The processes that the cell uses, the structure of the cell when it first developed would have looked nothing like cells, whether prokaryotic or eukaryotic, as they do today. And they would have probably developed more efficient methods for metabolism and all the other various processes that occur in the cell over the course of billions of years. The first protocells that developed were probably very, very, very simplistic.
Okay, what is usually asserted is that the smallest possible last universal common ancestor, or the first living cell, would be in 2016. They came up with the smallest cell, and they supposed that it would have about 500,000 nucleotides. Now, they also frequently mention Mycoplasma genitalum as a possible candidate, as the smallest possible form of life. Now, the problem with this, Leo, is that these candidates, they do not synthesize amino acids by themselves. They are not free living. Mycoplasma is a pathogen which lives in the human body, so it needs a host organism where it can import its nutrition and also the amino acids which are required. Now, we need as a model a free living organism which produces by itself the amino acids. And an example would be, for example, Pelagibacter ubique, which is a free living bacteria. It is one of the absolutely smallest organisms known, and it has about 1.3 million nucleotides, about 1,300 proteins, and it does synthesize the amino acids by itself. So that would be, in my understanding, a threshold of the smallest possible free living cell organism.
So how do we know that the first cells would have had to have been free living? How do we know they didn't exist in some form of symbiosis with each other, and then that slowly, essentially evolved out of the picture through more complex chemical processes?
Well, as I said, the model is the smallest free living organism cell, which produces all the basic building blocks by itself. And that would be, for example, Pelagibacter ubique, which does this. And it is a model of one of the absolutely smallest free living life forms, which we can use as a threshold to go from non-life to life. And it uses about 1,300 proteins. Now, this is already an astronomously huge number, especially in regards of the number of nucleotides which are required, which is 1.3 million nucleotides. If you make the calculation, what would be the chance to have the right sequence of that size and number of nucleotides randomly? It is 1 to the 10th to the 720,000. This is absolutely out of anything imaginable that it would be possible randomly. We have 10 to the 80 power of atoms in the whole universe. So it would simply be in the realm of the impossible.
As it relates, first off, they're talking about free living cells. What if the first cells were not actually free living was the question I'd ask. So we can't go off of the assumption that they were. We don't know if they would have been or not. We don't really know what the first forms of proto-life would have looked like. But because I hear a lot from intelligent designers this, well, the chances of this are 1 in 10 to some astronomically large number. So Otangelo, I'm assuming this has probably happened to you. I don't know if you've ever, I'll just use rain because I don't know if you've actually ever, I don't know if they get snow in Brazil, to be completely honest. So if you've ever walked outside and you've had a raindrop land like right on your eye, right on your eyelash, what do you think the odds of that one particular raindrop landing on your eye or your eyelash at particularly that moment? I mean, if the wind had just blown just a little bit in the right direction, if you would have been just a fraction of a second earlier or later stepping out of the door, that wouldn't have happened. So wouldn't you say that the odds of that happening are 1 in 10 to whatever astronomically large number we could probably come up with? Because those kinds of events happen all the time. The odds of winning the Powerball in the United States is 1 in like 290 million. People win the lottery all the time. The odds of 2 protons tunneling through their Coulomb force and fusing in the cores of stars is like 1 in 10 to like the 16th or something, yet we see stars running just fine. Chances can be high for things and they can still happen. And also, when we're trying to figure out the chances of something that's already happened, since it's already happened with down a particular pathway, of course the odds are going to be extremely high. There's chances that other pathways could have been taken, and any one of those pathways is going to have an extremely high odds of that particular pathway being taken. But we know that these things happen because we observe them happen.
Well, the problem with your rationale, Leo, is following. Of course, any random number is equally improbable to happen. But if you want to have a very specific outcome, then the situation changes. So
how do we know the outcome would have had to be specific?
Well,
how do we know that it wasn't like developed, evolved?
Well, first of all, because a cell is a factory, and factories do not simply assemble randomly. That would be like Hoyle's analogy, where he says that a tornado going on a junkyard would produce a jumbo jet. Of course, that is absolutely insane to believe that, but that analogy is actually very appropriate in regards of cells, because cells, they are factories full of molecular machines, and they are made through the genetic code, which is actually prescriptive information, which directs the make of the molecular machines, the proteins, and the assembly entirely of the cell. So we have a perfect analogy here, which and the origin of a factory, of course, cannot be random. And that holds also in regards of cells, which are in a literal sense factories which produce their chemicals, their basic building blocks through molecular machines.
Wait, you said stars are well, because I was thinking of another analogy. That's why I said stars. You said that cells are literal factories. You mean there's buildings inside of a cell and there's little people working on an assembly line inside of them?
Okay, factory, that comes from Latin, and it means fabricare. That is making, producing. And that is precisely what cells do. And there are many analogies
That would
that
just be a genetic fallacy that because this is how the word originated, that we have to use that meaning. That's not what factory means today. And having asked actual PhD biochemists, cells are literally not, they're not literally factories. That is a useful analogy because a lot of the processes that happen in them and how they produce different things is analogous to people producing something on a production line in a factory. If cells are literally factories, then you would have to agree that stars are also literal factories because stars also produce things through complex chemical processes. But I can tell you, as somebody who has sat down with over half a dozen astrophysicists, that stars are not literally factories, and neither are cells. That is a useful analogy.
Okay, I will read you some titles of some science, peer-reviewed science papers, and even books. The molecular fabric of cells.
The title isn't what matters. What matters is the minutia within them. And I can almost guarantee that if I read these papers and looked into the minutia of them and then cross-referenced them with other professionals in the field, I would find that these are being used analogically as descriptions, not as ontological prescriptions of what a cell is.
Okay, the book, The Molecular Fabric of Cells, starts like this. The central theme of both of these texts is to consider cells as biological factories. Cells
to consider them as
can I finish, please?
Yeah, sorry, crack on. Sorry, yeah, we'll just get the point finished.
Cells are indeed outstanding factories. Each cell type takes its own set of chemicals and making its own collection of products. The range of products is quite remarkable and encompasses chemically simple compounds such as ethanol and carbon dioxide, as well as extremely complex proteins, carbohydrates, lipids, nucleic acids, and secondary products. And I would like to mention another book. The book Science Matters from Robert Hazen. At page 239, he writes, cells act as chemical factories. And at page 240, nucleic acids, these molecules, DNA and RNA, carry the blueprint that runs the cell's chemical factories and also are a vehicle of inheritance, carbohydrates. While proteins supervise the cell's chemical factories, carbohydrates provide each factory's fuel supply. Like any factory, each cell has several essential systems. It must have a front office, a place to store information, and issue instructions to the factory door to guide the work in progress. It must have bricks and mortar, a building with walls and partitions where the actual work goes on. Its production system must include the various machines that produce finished goods, as well as the transportation network that moves raw materials and finished products from place to place. And finally, there must be an energy plant to power the machinery. Then cellular factories consist consists of walls, partitions, and loading docks. Every living thing is composed of one or more cells, each of which has a complex anatomy. A genetic cell contains many structures and organelles, tiny chemical factories. Today, there are professional journals specifically devoted to the research into cell factories. A recent article appearing in one such publication explained further the opportunities for the engineered improvement of the cell's innate manufacturing ability. And I could go on and on. There are many, I cite more than 24 of science papers, peer reviewed, which mention cells as literal factories, which have production lines, and they have molecular machines. They have energy plants like ATP synthase. They have factory walls. They have import of materials. They have export of waste products. They have the control system, which is the genetic information. So we are talking here, Leophilios, of literal nanofactories, not in an analogous form, but in a literal sense.
Can I just drop in for 1 second? Sorry, Angelo, sorry. So just somewhere, I don't think anybody's disputing that you can analogize a cell with a fact. You can use it as an analogy. I do that with the kids when I'm teaching them at school all the time. I talk about cells being like factories, etc. So no, I think we totally understand your point, what you're saying there now. Leo, how do you want to respond to that?
Well, the funny thing is, in pretty much every citation he gave, it says it acts as a factory or can be considered a factory. Language that you would use if you were.
I'm going to let Leo finish this bit, and then we'll come back to you, Angelo.
As analogies, and I've never met a professional that would say a cell is literally a factory, because it's not made of brick and mortar. Like, literally, cells are not buildings; they're organic material that's come together. Because these are analogies, and I just went to Google, and from ResearchGate.net. We have this quote: with advances in physiology and the rise of modern biochemistry in the early 20th century, the chemical factory or laboratory became the dominant metaphor for this biological unit. Today, in the 21st century, the metaphorical imagery has become a reality, with cells acting as chemical factories for the synthesis of commercially valuable bioproducts. The history of the cell shows how metaphors act as conceptual tools with particular strengths for facilitating different sorts of questions and experimental techniques, end quote. So we see that the professionals, anyway, are using this metaphorically. Have you ever heard of the phrase confusing the map with the place, Angelo?
Well, you are denying what I just wrote to you.
No, I heard you. They just use the same language I did. It acts as a factory, but it's not literally a factory. It could be considered one. But back to my question, have you ever heard of the phrase confusing the map with the place?
No.
So this analogy is used when somebody takes the description of something and confuses it actually with the something. So I live in the United States. If somebody took a map of the United States and confused the way that it describes the United States with what the United States actually is, that would be confusing the map with the place. That's what you're doing with the cell. You're confusing the analogical descriptions of what it is with what a cell actually is. Likewise, somebody who says, well, a star is literally a factory when it's not, would be doing the same thing. This is an analogical description of what something is, because it helps us to conceptualize what it is, especially as Baldicats just said, to explain it generally to lay people. These are metaphorical descriptions that make understanding the minutia of what we're explaining more palatable to somebody who might not have all of the technical understanding of it. But no astrophysicist is going to say that a star is literally a factory. And I would bet any written amount of money that no professional biochemist or organic chemist would state that a cell literally is a factory. And if I were to Google the word factory, I feel that definition would probably not line up with what a cell is. In fact, I'm going to do that. And the definition of a factory is a manufacturing plant or a production plant, and it is an industrial site, usually a complex consisting of several buildings filled with machinery, where workers manufacture items or operate machines with process items into each other. Well, that's not a cell. A cell is just a complex structure consisting of numerous different structures that carry out numerous different chemical processes. I agree, it is analogous to a factory, but it isn't literally a factory, because factories are things explicitly built by human beings.
Can I just ask, and I'm sorry for jumping in, I am sorry, but I'm getting a little bit lost, and I'm just, maybe some people in the chat will be as well. I get that we're talking about a factory, a cell, as whether it is a factory or whether it's analogous to a factory, but can you just clear up for us, Angelo, please, because I know it was your argument you brought. Can you clear up how that relates to the topic of abiogenesis? Like let's say we concede and we say, you know, a cell literally is a factory. How does that relate to the argument? That's where I'm getting a bit woolly.
It is of absolute importance. Katz, correct? Your name, Katz?
Yes. So yeah.
Okay.
So yeah.
So I will explain you why. Actually, at the beginning of our chat, someone asked, well, what is the profession of these guys? So I am a machine designer. So I design machines. And so how does that happen? When my boss comes to me, he says, I need that you make a machine with that specific purpose. And these are the dimensions, these are the materials, these are the sizes and so forth. The purpose of that machine is to produce X. Okay, I will sit down, I will make the project, I will draw the parts, the individual parts of the machine, I will select the materials, I will produce the drawings of the individual parts then of the machine in its entire form and with all the dimensions and everything descriptive which permits the drawings to go to the factory, and then the factory workers, they will take that design and they will read the information, and based on that information, they will produce that machine. They will make the order of the parts of the materials, of the building materials and so forth, and then they will produce that machine. And this is analogous to what happens in the cell. And even in the most primitive cell, it happens that way. You have a genetic code and genetic information, which is prescriptive information. It is prescribed. It is instructional information, which instructs the cell how to make proteins, which are molecular machines in a literal way. This is not analogous, but this is in a literal sense. They are molecular machines because they manufacture things. They have a specific purpose to make things inside of the cell, to make chemicals, to make lipids, to make amino acids, to make nucleotides, to join them together, to make the cofactors of the proteins, and so forth. So what we have here is actually an analogy of what we make as humans and what happens inside of the cell. Now, let us suppose that you arrive at a distant planet, and there you see a library, and you go inside of the library, and you have no idea who or what made that library, and there you see a book, you take it out of the shelf, and then you open the first page of that book, and there you see an engineering plan of a precise instruction to make machines and a factory. And then you see a few pages further, and then you see the factory and the machines made precisely upon the precise instructions of that blueprint, of that plan. So you have no idea who made neither the blueprint nor the factory, but you have two possible explanations. One is that some aliens made the factory and the blueprint, and the other is that by chance, by random unguided events, both came suddenly into existence just by the environmental conditions. So what would be the better explanation? That some intelligence made the blueprint and the factory depicted in the book, or that it was just random forces that somehow through millions of years of random actions and natural forces produced the book the blueprint and also the factory. That would be basically the two options that you have to choose from, and that applies as well to the cell.
That would just be a false analogy because cells don't have blueprints. They just have chemical reactions that take place. And most of the chemical reactions that occur in both prokaryotic and eukaryotic cells today most certainly were not present when cells first arose.
So, Leo, what is the function of DNA?
What is the function of DNA? Generally to code for proteins.
Okay, and is the sequence of the nucleotides relevant?
Of course.
So you have a blueprint.
Yeah, we call it that, but that's not what it is. It's just a chemical compound that can do some stuff.
Okay, the chemical compound.
Different chemical chemicals, that would be like saying, well, carbon dioxide is a blueprint because carbon dioxide can react in different ways with other chemicals depending on what those chemicals are. Or I mean, if we're going to argue that DNA is a blueprint, then literally every molecule and every chemical is also a blueprint to some degree. I think that's an over trivialization of what a blueprint is, and an over trivialization of the analogy that is being utilized by professionals.
So what is the difference between software and hardware? I asked you this at the end of our last debate, Leo, and we had not enough time to figure that out. So I think it is a good moment to continue precisely with that question. Can you answer my question, please?
Hardware would be pretty much this phone and everything that all of the motherboards and everything on it. And the software are all of the algorithmic productions that humans programmed that run on that hardware.
Yeah.
So like
exactly.
Facebook would be software, the computer that it runs on would be hardware.
Exactly. And that's the same thing that you have in the genome. You have the hardware, which is the DNA. Can I finish, please? That is the hardware, which is the DNA molecule. And then the specific sequence of nucleotides, they are composed of the genetic code, which is the language, and the specific sequence of codons, they are required to instruct the precise sequence required for the amino acids to make the polymerization and to have the right sequence of amino acids, which will form then the protein, which then will fold into 3D form and turn into a molecular machine. So the sequence of amino acids, Leo, is absolutely essential. You cannot have just any kind of amino acid sequence. You need the precise, correct sequence of amino acids in order to get the folds and a functional protein. And what instructs that sequence is the DNA information, the sequence of nucleotides, and the sequence of codons. So we have there, in a literal sense, a blueprint, prescribed information, and an algorithm which instructs how to assemble the amino acids in the right sequence. And that's the software of the cell.
Except that there's no software because you just yourself admitted it's dependent on the structure of the physical molecule. So it's literally just a molecule. The way that it's structured, because of how they're doing, there's four different nucleotides. The way those are structured determines the type of chemical reaction that takes place, which in turn determines the type of reactant you're going to get. So it's literally, like I said, we can see that with molecules outside of DNA, outside of anything that's even remotely related to what life is. But those aren't software. It's just molecules. It's just chemical reactions occurring based on the structure of molecules. Change the structure, you change the chemical reactions.
That would be the same thing.
That's literally just basic chemistry.
Is that logical or sound?
Of course it is. Yeah.
Oh, yeah.
There's nothing logically preventing that sentence from appearing in the clouds. There's a lot of different shapes. I know people that see dogs in the cloud. Does that mean that some intelligence made a cloud into the shape of a dog? No. And again, chemical reactions are taking place. There isn't a language here. If there is, I want somebody to write that language out for me and tell me what it is. I mean, French is a language. English is a language. DNA is a molecule. There's a difference between languages and molecules. Again, these are analogical descriptions that are utilized by professionals to parse out the more intricate aspects of what's going on. They're not ontological prescriptions of what something is.
Okay. Let me read here from Wikimedia, okay? In the alphabet of the three-letter word found in cell biology are the organic bases, which are adenine, guanine, cytosine, and thymine. It is the triplet recipe of these bases that make up the dictionary we call in molecular biology genetic code. The codal system enables the transmission of genetic information to be codified, which at molecular level is conveyed through genes. And that biologic systems and processes cannot be fully accounted for in the terms of the principles of laws of physics and chemistry alone, but they require, in addition, the principles of Can I finish, please? They require, in addition, the principles of semiotics, the science of symbols and signs, including linguistics. And it identifies 13 characteristics of human language. DNA shares 10 of them. Cells edit DNA. They also communicate with each other and literally speak a language he called cell-easy, described as a self-organizing system of molecules, some of which encode, act as signs for, or trigger gene-directed cell processes. I can go on and on. So
yeah, we use semiotics analogically to represent what DNA is and what it does. Again, these are just analogical descriptions.
Well, another citation here: the language of DNA is digital.
But giving more citation doesn't refute the statement I just made. These are still analogical descriptions. They're not ontological prescriptions.
Well, you are literally wrong, Leo.
No, definitely not.
Okay,
because the professionals are saying what I'm saying. So if I'm wrong, you're saying the professionals are wrong. And neither of us are professionals, so I feel more comfortable deferring to their expertise.
Okay, so does DNA store literally coded information? Yes or no?
It doesn't store information. Its structure is information. Like, for instance, electromagnetic radiation doesn't store information. It is information.
Okay, I will contradict you with citing an article in Nature magazine from Hubert Yockey, the world's foremost biophysicist and foremost authority on biological information. And he contradicts you 100%. Information, transcription, translation, code, redundancy, synonymous, messenger, editing, and proofreading are all appropriate terms in biology. They take their meaning from, can I finish, please? They take their meaning from information theory and are not, can I finish, please, Leo? And they are not synonyms, metaphors, can I finish, please? And are not synonyms, metaphors, or analogies.
Yeah, but they are, though.
And they continue. It is, well, you know, it seems you know it better than Jockey then.
Well, that's one person.
Can I finish?
The vast majority of the field.
Can I finish, please? Leo, I would like to finish.
One person.
Can I finish, please?
Doesn't refute.
Well, I have a long list here which confirms what I am saying. I have here another article from DNA, from the Royal Society, DNA as information. The biological significance of DNA.
Well, I never denied DNA.
Can I finish, please? Can I finish, please?
Can I just step in for 1 second? Sorry, guys. Can I just step in for 1 second? I think I know where the frustration's coming out. I think, Angelo, we get you. If I'm right, I think the point that you're going to make through the articles that you have is that some scientists refer to DNA as storing information. Am I right? That you're going to have a lot of citations that.
Well, this is the general consensus all over in biology.
And I think Leo's view, and again, Leo, tell me if I'm wrong. I think what Leo's saying is essentially that the DNA isn't a molecule that you could overwrite information on, like you might get on a microchip or something like that. It's a physical molecule that has a structure, and that structure, you know, we can analogize it as being used for information. But again, I'm going to have to take a step back and say, okay, is that just a play on words that we're discussing now? What is the actual? And I'll pass this on to Leo, and then you can respond to Leo. But what is the actual relation of that to the topic of hand, which is, biogenesis? Like how? So, like, because I'm getting a bit confused. Leo, can I pass it over to you, and then have a couple of minutes, and then Angelo can answer your points?
Yeah, no problem. So the relevant, I don't see how this is relevant because, I mean, it's already been well established within the fields of molecular biology and biochemistry that these are just analogical descriptions of what's going on, because humans are limited linguistically in how we can describe things. And humans have been using analogies to describe things since there have been humans utilizing language. It's important for intelligent design proponents because they want DNA to like literally be a code and literally be a language and all of these things, because then they can make the argument, well, see, those things don't arise naturally. They have to have a designer, which is why they think it's relevant, but nobody in the field actually believes these things. I mean, even Francis Collins, who himself is a Christian, doesn't really agree with these points that, well, DNA has to have some sort of designer. And like I said, he's not just one of the foremost geneticists on the planet, he's also a Christian and doesn't even think this. And the vast majority of the field agrees with him on that. I mean, I have numerous sources: Advancing Health Literacy, a Framework for Understanding and Action, Stanford University Press, When Genes Become Information, specifically in quotes, The Meanings of the Gene, Public Debates and Human Heredity, code between operation and narration. I mean, numerous differences where they all talk about how these are all analogical descriptions of what's going on because one, humans are limited in their linguistic descriptions of what things are and how they work. Number two, humans frequently use analogies to describe things. And three, because these are useful. The problem is that they've been so ingrained into the field that lay people take them seriously and think that DNA literally is some type of code that does some type of programming when those are just analogies that we utilize because it helps us understand what it is.
Well, the genetic code is named as a genetic code not for nothing. It has a reason. But I would like to read here just a syllogism, which I think will make it very clear what I am talking about. Algorithms prescribing functional instructions, digital programming, using symbols and coding systems are abstract and non-physical and originate always from thought, from conscious or intelligent activity. Genetic and epigenetic information is characterized containing prescriptive codified information which result in functional outcomes due to the right particular specified complex sequence of triplet codons and ultimately the translated sequencing of amino acid building blocks into protein strings. The sequencing of nucleotides in DNA also prescribes highly specific regulatory microRNAs and other epigenetic factors. Therefore, genetic and epigenetic information comes from an intelligent mind. Since there was no human mind present to create life, it must have been a supernatural agency. So what I want to say with this, and I want to make it very clear, is that the particular specified complex sequence of triplet codons is what ultimately is translated to make amino acids and then proteins. That sequence is not random, it is complex and specified. It is instructional. It instructs the specific complex sequence of amino acids, which must be very precise to have functional proteins. Now, you have two possible explanations where that sequence comes from. One is random chance because there was no evolution prior to life starting and self-replicating. And the other option is intelligent design. And I, as a machine designer, I know that only intelligence can make instructional information, which then results in the make of molecular machines or factories or functional integrated products. Random chance has not the chance, is unable, is too unspecific to make a specific outcome like this. And we are talking here about a sequence of at minimal 1.3 million nucleotides, which must be sequenced in a very specific non-random order.
Well, now they must be, but when DNA first developed, which DNA wasn't even the first chemical, it would have been RNA, and the way that it's structured, I wouldn't really say it was random, but it was selected for through particular environmental pressures and what worked and what didn't work. And it's now, we still see that there are problems in DNA. DNA is not like this perfect thing that works all the time. That's kind of why humans consistently have diseases that are based in genetics, because DNA is very, very wild, and there are a lot of problems with it. But there was something that's from the Stanford University Press that I wanted to read here because I think it's very important. Quote, "Yet, as the author points out, these are just metaphors, analogies, not ontologies. Necessary and productive as they have been, they have their epistemological limitations. Deploying analyses of language, cryptology, and information theory, the author persuasively argues that, technically speaking, the genetic code is not a code, DNA is not a language, and the genome is not an information system. Objections that were voiced by experts as early as the 1950s," end quote. And from 1953, when genes became information, volume 153, issue 3, April 2013, pages 503 through 506, The gene had entered the computer age. According to this metaphor, not only did the genetic code contain information, but this information had a special kind of meaning to it. It was a program, a set of instructions that enabled the cell to carry out a particular activity. However, it is easy to forget that this is a figure of speech rather than being literally true. A gene is like a program, but it is not a computer program and does not function according to the same rules. Similarly, the genetic code is not literally a code. It is a process that enables organisms to carry out particular functions by turning stored information into structures or actions using evolved rules, end quote. So the field does not agree with the conclusions that Otangelo is reaching, and they are conclusions often reached by lay people who haven't actually analyzed the structures and the functions that are occurring at the level that most people with a PhD or even a master's degree have. And that is why they disagree with these attempted ontological descriptions and have to consistently remind people, no, these aren't literal descriptions of what these things are. They're analogical descriptions of what they look like to us that help us understand what they are. But I think at this point, I'm kind of just beating a dead horse. I would rather move on to an actual intelligent design model, as in like something that we can test that definitively demonstrates the viability of intelligent design, because nothing like that has been produced ever.
Well, I would like first to make a point and ask you, do you actually even understand, Leo, what you are reading now? So
yeah,
we will see. Okay, so
why would I read something I don't understand?
Okay, so please explain to me, what is the function of codons?
Codons? I think they assist in the development of proteins.
So how exactly does that happen?
I believe through the I always get these two backwards. Is it transcription that happens in the ribosome, or is that, yeah,
translation in the ribosome? Transcription makes the mRNA, and translation in the ribosome.
I get those two mixed up every time. But yeah, so I think I would say that is a processes that probably weren't around when life first developed. In fact, we know those processes weren't around when life first developed. And that's the problem, is that we're taking life as we see it today, the processes and the structures in it today, and extrapolating that to billions of years ago, when literally no relevant professional is going to say that you can do that. These processes, these structures, these functions did not exist when life first developed, because DNA didn't even exist when life first developed.
Wow. Wow. Can you give me an example of a life form which doesn't use DNA, Leo?
Well, no, because all life forms today use DNA. They would have outcompeted those that didn't, because obviously DNA is a better mode for storing that information than RNA is. That would be like asking, that would be like asking if there are things that humans used way back in the past for building buildings. Do we see any humans using those today? No, because better technologies have been developed. That's kind of the whole point of evolution.
So how do you know that a life can exist without DNA if there is no example?
Because we know that DNA didn't exist when life first developed.
How do you know that?
Because it was RNA that existed when life first developed.
So is there an example of a life form which only uses RNA?
Well, actually, technically, most life is still RNA based. It's mRNA that goes. It's mRNA that is what is transcribed. It's tRNAs that bring the amino acids to form the polypeptide chains. It's the mRNA that is translated to form that. The DNA just stores the information. It doesn't really do anything. And there's been 2 PhDs that have told me, really, life, if you really want to think about it, is still RNA based.
Okay, Leo, I think you will not have enough time, but when this debate ends, I give you a challenge. Demonstrate to me a life form which doesn't use DNA. That's the first thing. Now, the second thing.
Well, I've already explained why we don't see life using DNA. Just reiterating the same challenge doesn't do anything when I've already addressed
I mean,
that.
You make just a baseless claim.
Well, no, because I've asked professionals that same thing, and they told me what I told you. Because DNA was not around when life first developed. DNA began to develop. Life forms were better capable of surviving if they utilized DNA. So the ones that utilized DNA essentially began to dominate the planet. And now we don't see any that utilize RNA, because those days were outcompeted.
And the ribosome is also not. And the ribosome is also not required, right, Leo?
What, for early life? Probably not.
Oh. Okay. Okay. I
See,
will
and,
just.
and this is the problem with people that posit intelligent design. They think that literally all these things just poof, and there it was, exactly as we see it today, billions of years ago, despite the fact that literally none of the data agrees with that, and no professional would honestly take that seriously.
Okay. After we finish, Leo, show me an origin of life research paper which does not include the ribosome in a minimal protein set required for the last universal common ancestor. Okay.
Well, universal common ancestor and the development of the first forms of life are two completely different things. It's also worth mentioning that when life was first developing, it's not like you could draw a hard line and go, this side is not life, this side is life. There was probably a mix of things that we might have considered life, other things that we wouldn't really consider life, but are close to it. And then it would have been much more of a gray area. And again, these are things that professionals have told me. And especially since I've been on YouTube with the people that I associate with, I've been in contact with a lot of people with masters and PhDs in molecular biology, biochemistry, organic chemistry, evolutionary biology, and they are all agreeing with me and not with what the intelligent design proponents are saying. I would wonder why.
Oh, okay. So let me ask, let's go back to codons. Are codons assigned to amino acids, Leo?
I really don't know if that would be the proper way to word it. I don't have a professional on hand to ask them. And like I said earlier, when I don't know, I defer to the experts. I don't make my own conclusion.
What was the question, Angelo? Sorry, what was the question?
He asked if codons assign amino acids, and I said I don't know if that's the right way to word it. I'm sure in an analogical sense, yes, you could say that. But the point that I'm getting at is if I don't know something, I defer to the experts who do, rather than coming to conclusions that support, or rather making assumptions about how something works that would support preconceived conclusions I've already convinced myself of, which is pretty much the basis for intelligent design.
So you are pretty contradicting yourself, Leo, because previously you said that you cited something which you understand, that you understand what the genetic code is about, and now you are confessing that you have actually no clue. So what is it?
Wait,
now?
so you can't know different parts and then not know other parts?
Okay, I can't give you a little instruction.
I understand like the basics of quantum mechanics pretty well. I still don't really know what perturbation theory is.
Yeah, but we are here about abiogenesis.
Yeah, but that was an analogy. I was presenting an analogy that people can understand large aspects of a subject while they still don't understand certain other aspects. There are professionals in this field that understand certain things but don't understand other things because their research is focused on a particular area.
Okay, so
it isn't an all or nothing thing, my friend.
Okay, so let me give you a little education here, Leo. Codons, they are assigned to amino acids. And there is an alphabet of 61 codons, which are assigned to 20 amino acids. Okay? And that is called either a cipher or a genetic code. And what makes that translation is the ribosome. Now, you have to ask yourself, how did that assignment without intelligence occur prebiotically, where the 61 codons, the triplet codons, were assigned to an amino acid? This cannot be an undirected process because selection is something that you can only do when you have intelligence involved. And this is a huge abiogenesis problem.
That's an assertion that needs substantive evidence provided in favor of it, and there hasn't been any yet.
Well, I can educate you a little bit further, Leo. There is a science paper written by Eugene Konin. You can look it up after our chat here. And he confesses that this is one of the biggest biological problems. There is no solution in sight to explain how the genetic code or the cipher emerged prebiotically and undirected by natural processes. Why?
Yeah, but that doesn't
because
mean intelligent.
can I finish?
I mean, that's literally an argument
can
of ignorance.
Can I finish? Can I finish, please, Leo?
Yeah, I'd like to take this point by point instead of you gish galloping.
Okay, let's do that. Let's just do one point at a time and then go. So just make that point. We'll let Leo respond to that point, but then we'll come straight back to you, Angelo, and you can do your next point, and we'll just do it one point and then back and forth. Okay. So address that specific point, Leo. Then we'll go back to Angelo, and you can make your second, and we'll do it that way. Is that okay for everyone?
Okay,
Yeah,
go
there's
ahead.
a lot
Okay,
there's a lot that scientists don't know, because science doesn't have an answer. Doesn't mean it was a magic man in the sky or some magical anthropomorphic immortal that decided to poof it all into existence one day. What it means is that we don't have an answer for it. We still don't know what quantum gravity is. We don't know how gravity works at the quantum level of reality. And over the last 100 years, we've gotten a little bit closer to potentially answering that question, but we haven't answered it yet. That doesn't mean that it's fairies or leprechauns or some magic thing that's doing stuff here. It simply means that we don't have an answer. To argue that, well, we don't have an answer, therefore it's this, is by textbook definition an argument from ignorance. You're just making an argument from ignorance. Science doesn't know, therefore it was this.
Well, there is a philosophical method which is named eliminative inductions. I don't know if you have heard about it. And it says when you have two possibilities and one possibility is not possible, and you have eliminated the impossible, everything that remains is the better option, even if you don't fully understand it. And we have, in regards of the origin of the genetic code, two options. Either it was set up by intelligence or it was set up by random unguided events. And
that's a false analogy. What is it? A false dilemma fallacy, because number one, an intelligence doing it isn't a possibility that's been established. You would first have to establish that possibility. That hasn't been done. That's just an assertion that an intelligence did it, but nothing that has ever been explained utilizing some supernatural intelligence. So there is no precedent, as T-Jump would say, and I love this, there is no implicit empirical basis for that being an explanation. So it would be like me saying, well, how do you know that fairies isn't a potential option? I mean, it's not, because there's never been a point where fairies have ever explained things in the past. But you know what has explained things? It's actually the only thing that's ever explained things? Nature. Because we can describe what nature does, but we don't need to assume that. See, it's a baseless assumption that, well, intelligence is an explanation. I mean, to some degree, yeah, but it's not one that anybody is going to take seriously to any degree, for the same reason that they wouldn't take seriously that it was fairies or that it was dragons or anything like that. Like, for the same reason that nobody's going to take seriously that lightning is the result of Zeus throwing down his bolts or Thor flying through the sky with Mjolnir. We don't need to make those assumptions. We don't appeal to magic when we don't have an explanation.
Well, intelligent design theorists like me, we do. The science fathers, they did. They were all Christians. But I want to come back to your method, Leo. There are actually basically just two possible mechanisms or explanations. One is which includes intelligence, and the other is which does not include intelligence. Can I finish, please? And
yeah, but you're repeating a point.
Can I finish, please? Yes, I would like to finish my point, please.
Yeah, but I've already addressed it.
I'll just jump in because we haven't got too long before we go to the questions. So what we'll do is let's do a bit of a sum up. Artangelo, if we come to you and you finish the point you want to make now and give a summary, okay. We'll then go to Leo to respond and give a summary, and then we'll go to the questions from the chat because they've got questions for each of you, and we'll continue the battle with the questions from the chat for the next 15 minutes or so. How's that sound?
That's great. Go ahead.
Okay, so yeah, finish your point, say what you need to say, wrap it up, then we'll pass it to Leo to have an uninterrupted say as well. Off you go, sir.
Okay, we use abductive reasoning to the best explanation, and the origin of the genetic code is better explained by an intelligent agent which did set up that code rather than unguided random events, because random unguided events, they do not create language, they do not create code, they do not create translation systems. And I can give a good illustration in regards of that. Let's suppose that you have the name chair in English, and the same name of chair in English, the name in Chinese is Shizi. Now, the translation from chair to Shizi requires intelligence, which knows the meaning of chair and knows the meaning of Shizi. And based on intelligence, we can make a translation book where there is explained what the meaning of both is. So this is an entirely intelligent-based process. And the same occurs in regards of the genetic code, where the assignment of a codon is done to an amino acid. And there is a meaning between the two. There is a genetic alphabet and there is an amino acid alphabet and there is a translation. That's why the ribosome is making a translation from the messenger RNA to amino acids. And that is a translation process which requires assignment of meaning of codon language to the meaning of amino acids. That is a cipher, and that assignment cannot emerge randomly by unguided events. It must literally be set up by intelligence. That's why I am an intelligent design proponent, because I cannot fathom, it is not imaginable that non-intelligent mechanisms can produce a translation book and can produce meaning and can produce assignment of meaning. And I use that as eliminative induction. It is not possible. And I use abductive reasoning to the best explanation, where intelligence is the best explanation to explain the phenomena in question, which is the origin of the genetic code.
Well, that is, again, by textbook definition, now that's a personal incredulity fallacy. Well, I can't fathom how this developed naturally, therefore it didn't develop naturally. It was magic. It was some magical anthropomorphic immortal that decided to poof it into existence.
That's not incredulity.
Would you say this is Leo's? This is Leo's.
I can't fathom how it was done, therefore it was this. Like, if you look up the definition of a personal incredulity fallacy, that is what it is, saying, I don't know what this is. I can't understand how this could have been done this way, therefore it wasn't done that way. That is literally what you just said in your own words. I cannot fathom how this could develop naturally, therefore it did not develop naturally. That, by textbook definition, is the personal incredulity fallacy. In terms of DNA being a code, a language, all this stuff, I've already addressed the fact that those are analogies. They're not ontologies, as pretty much every relevant professional in the field says. So at this point, it seems that we're just arguing in circles. Notice how we haven't seen a model for intelligent design. We don't have a mechanism for how it's done this. There's no precedent for intelligence designing things in a natural world outside of humans making stuff to make our lives easier. So I want to see a model, something I've never seen. I want it to make testable hypotheses. I want it to define a mechanism for how this whatever magical being that we're asserting did this, how it actually did it. Because if we're going to assert that these chemicals were just here and then poof, they existed in the structures that they needed just out of nowhere, that's literally an appeal to magic. And then we're arguing that magic is somehow better than science. On top of that, we're getting nothing but arguments from ignorance. Well, I don't know how this could have happened. We don't have an explanation for how this could have happened. Therefore, it couldn't have happened that way, and it had to be some type of God that did this, even though we don't know how he did it. We don't know when he did it. We don't even know if this God is real. I would argue that life could have been intelligently designed. But if it wasn't a God that did it. It was probably aliens, because that's the only other thing that we can think of that exists in reality that would have had the ability to interact with the natural world in a way that produces anything. So there's a reason why intelligent design proponents just like to poke holes in the abiogenesis hypothesis and argue, well, it hasn't explained this, it hasn't explained that. Well, neither have you. You're just asserting that this is what did it with no explanation of how that occurred. And this is the problem. It's okay for intelligent design proponents to have a model. Well, it's not really a model, it's just an assertion without a mechanism, but where we have actual things that have been tested and experimentally demonstrated in the lab that are showing great promise to answering these questions. That's all dismissed because it doesn't show that my magical anthropomorphic imaginary friend did it. And I think that it's disingenuous at best and dishonest at worst.
So,
okay, can I answer to that, please? I would like to answer.
Do you want a quick minute to refute each other there, and then we'll go to the questions, yeah?
Well, he can have the last word since I went first, so.
Okay. So my argument that the origin of the genetic code is an argument from ignorance, I refute that because we know by experience that intelligence is always required in order to make an information storage mechanism, which would be the DNA molecule, then a language, which is the genetic code, then information, which is the information stored, the sequence stored in the genome to instruct how to make the proteins, and then information transmission systems, which is the transition from DNA to RNA polymerase by transcription, and then messenger RNA goes to the ribosome and it is translated. That is an information transmission system. These are 4 parts which are irreducible and which have to merge together in order to function. So we know by experience that intelligence does by routine make such kind of things. It does produce information systems and transmission systems. We have absolutely no evidence that random unguided events can produce the same issue in question. So science is confirming that they have no explanation in regards of this. So that is evidence that it is not possible. Intelligence is the best explanation. And in regards of a model, which Leo asked, well, how did God do it? Well, we know that intelligence can make blueprints, can make machines, can make factories by experience, because we as human beings can do that. So we can transpolate that to a creator which is far, far more intelligent than we are, and making cells and life, which is far more complex than anything that we have ever produced. So I completely reject the argument of Leo that we are talking here about an argument from incredulity. I am making a positive case of intelligent design.
Okie dokie. So that's excellent. You both give a really good account of yourselves there, and I've really enjoyed listening to that. But the chat do have some questions for you, so we're not quite done yet. If you've got another 10-12 minutes for us, is that okay, gentlemen?
Yeah, totally.
Fantastic. Just for the chat, I have put a link to the community page where we've got the questions. That's where I'm going to be reading. Oh, Creaky's back. Hey, Creaky, how are we doing, sir?
Wonderful. We have had one super chat.
Ooh, super chat.
From Digital Demonic Davros, $5 Australian. I'm prepared to yell at anyone for these days of misunderstanding things that have empirical evidence. You know facts. That's what we try to show was wrong. And Harry Hillicus has become a channel member. Thank you, sir.
Oh, thank you, Harry. Okay, so Atangelo, the first question is for you, and it's from Bacon Earth. He says, do you accept that it is possible that your understanding of God is based on the writings of man and therefore could be completely wrong? And that acceptance of the understanding provided by the scientific evidence does not have to remove God?
Well, of course, it could be wrong. I mean, I'm a Christian. I believe that the Bible is the inspired word of God, and it could be proven wrong. For example, if the bones of Jesus would be found, then of course the resurrection would be falsified and would not be true. Since that is not the case, I keep remaining a Christian. What was the second question?
Oh, the second one was, do you understand that accepting the scientific evidence does not necessitate removing God?
Absolutely not. Of course not. I mean, the evidence is what we try to make the interpretation where it leads to. And we try to be unbiased and permit to lead it wherever it is, either to God or to natural mechanisms.
So by extension from that, and maybe this is where Bacon, I don't want to put words in his mouth, but maybe this is where he's getting at. An actual extension of that is, given that the scientific evidence, for example, leads to evolution, are you prepared to accept evolution while still believing that God is the person who chose to put evolution in place?
Well, I would be very happy to have a debate with someone that is a proponent of evolution, because it is, of course, a very huge topic, and it is decades that it is debated if evolution is true, if it is the real mechanism to explain biodiversity. And I have a different understanding of what actually the real mechanisms are which produce biocomplexity and biological form and architecture. And it is a very interesting topic. I've not yet had the opportunity to debate that. And if it comes up, if you search to me an opponent, then I will be more than happy to debate that.
I'm sure it might happen.
Yeah, but I accept evolution partially in regards of adaptation to the environment. That is a proven fact. There is no dispute. What is in dispute is common ancestry, and that evolution by natural selection and mutations, genetic drift and gene flow, that these are the real mechanisms which explain all biodiversity on Earth. And I reject that. In my understanding, it is mostly epigenetic information and epigenetic codes and signaling and languages, which are the real mechanisms. And it is far more complex than just genetic information.
I'd like to provide a comment, not to anything
Yeah.
that Otangelo said, but to the question, if I may, because I think it's a really good point. So in terms of a second question, this is something that I try to drive home with a lot of people who believe in God, is that even if life did develop through natural processes and natural processes alone, that has no bearing whatsoever in and of itself on whether or not God exists. So God could still exist, and literally everything that happens in the natural world is entirely natural. That has no bearing on whether or not a God does or does not exist. And I just think that that's a really good point to make.
I that's my personal stance. None of the not that I'm in the debate, but nothing that we see or observe or scientific depends on the existence of or the non-existence of a God.
Exactly.
Creaky, do you want to pick a question?
Yeah, just before I pick the next question, somebody in the side chat has volunteered themselves to debate on biblical evolution. So, Round Thinker, if you want to shoot us an email.
Oh, Round Thinker, yeah, I've got him on the Twitter as well, actually. So we'll set that up. So if you're happy to come back and do a debate on biblical evolution.
Yeah, sure. I mean, not. I wouldn't say that evolution is biblical, but yeah, I'm open to have a debate in regards of evolution and if it's sound or not.
Oh, we'll set that up for you, sir.
Sounds like fun.
Right, the next question is from, that's not even a word, SMLBSTCBR. Who created the creator?
Well, God is eternal. He has no beginning. And of course, something cannot come from absolutely nothing. That means that something must have existed eternally without a beginning. And since it was not the universe had a beginning. So it must have been a God, which is a self-existent, necessary, eternal being without beginning and without end.
So God's not...
I did want to throw out really quick, just really quick. And I'm not going to do this with every question. Just the whole who created God thing to me is just, and this is just my personal take on it, is a really bad argument, because it just, if you are a positive atheist, a philosophical atheist, there are so many ways to better argue against the existence of a God than asking that, in my opinion, rather asinine question. And just what Otangelo said reminded me of something. If you guys know of anybody, or if there's anybody in the side chat that would, or that knows anybody that would want to debate the Kalam cosmological argument, I've been looking to have a debate on that for over a year. Whether it be on this channel, I've told James from Modern Day Debate to keep me in the loop if he knows anybody. He hasn't found anybody that wants to debate that. Funnily enough, a lot of theists like to utilize that argument, but nobody wants to actually debate me on it. It's disconcerting, I must say.
If we can set that up, that'd be amazing to have.
Well, Leo, I would actually even debate you on that topic. But first of all, I need to understand how you can prove that time is tenseless. That is something that you said that you explained it to me already, that I didn't listen to you and so forth. Yeah, that's possible. And I have to dig deeper into that issue, that question, to have actually a basis to have a chat with you on that.
I would recommend special relativity if you're going to be looking into that.
Yeah, as I mentioned other places, I'm not good in mathematics, so I don't know if that is a pre-requirement. Then maybe I'm not the best debate partner in regards of that topic.
Right on.
Creaky, is it me?
It's your turn. It's your turn.
Right. John Harding, Otangelo, says, can you give an example of special creation from the beginning life, as you seem to think that an example of abiogenesis is needed? So have you got an specific example of special creation?
Well, I believe that everything was created by God, starting from the universe to the chemical elements, to the galaxies, to the planet Earth, to the moon, which is everything finally adjusted and tuned in order to permit life, to the origin of life, biodiversity, consciousness, morality. Everything, in my understanding, was created as explained in Genesis in the Bible.
Leo, anything you want to add to that?
No.
So, back over to you then, Creaky.
Next one is from John Harding again. If you Google Otangelo and Atheist Experience, you can see him failing with the exact same arguments, and also on Talk Heathen and lots of other YouTube channels. He uses exactly the same script every time.
Have you ever, I'd say, have you ever come across, has anyone ever said anything that's made you question your stance in all those debates? Or, you know, you're very happy that your stance is comes out on top?
Well, my friend would have first to substantiate that I failed with my arguments in my call-ins to Talk Heathens and the Atheist Experience. So I'm more than happy to have a chat on whatever call-in that I had there. And if the person that is claiming that I failed can explain it and point it out in what sense and how I failed, and then I can consider it. But I don't agree, and I don't think that I failed. Actually, especially when I called in at the Atheist Experience, Matt Dillahunt, he basically did hang up on every and each of my calls, and I asked him to have a formal debate. He refuses. I had recently an email exchange with Aaron Ra. He refuses to debate me, and I am open to have a debate with any of these people in a formal format where they cannot hang up on me.
Okie dokie. Oh, it's me, isn't it? Yeah. From Crouching Tiger, Hidden Adam. Hello, sir. Question for both of you. So we'll start with you on this one, Leo. Are humans any good at comprehending large timescales and large distances? Are humans any good at naming things, particularly physicists? I think that's probably in the relation to the analogy section of the debate.
So as for the first part of the question, absolutely not. I mean, the Earth has been here for 4.54 billion years. Humans live, and even this is being generous, but I mean, it's a good number to round up to, on average for 100 years. This is part of the reason why there have been aspects, mainly at the relativistic scales of reality, you know, the cosmological scales, that we don't fully understand how galaxies form. We don't fully understand numerous things about these because we're not privy to the time scales. And we're also not privy to the distance scales. I mean, you can go from, I think, New York to London in, what is it, like 6 hours, 6.5 hours, something like that, to go, what, 3,500 miles? The sun is 93 million miles away. It takes a couple months, I believe, to get a satellite there, or not a satellite, but any observatories there to observe the sun. It would take, I think, what is it, like 35 or 40 days to send somebody to Mars. If we were to send them to Mars, Mars is 42 million miles away from the Earth. So, but in short, no, humans are not privy to those time scales and those distance scales. We have a hard time really understanding them. In terms of physicists, are physicists bad at naming things? I would say that in some respects, yes. I think the word quark, I think calling them quarks was the most idiotic thing ever, because everything else ends with on. You've got the electrons, leptons, bosons, gluons, photons, and then quarks. Why not just call them chromons? Since it's quantum chromodynamics that governs their interactions and their behavior, chromons, I would say, would have been a much, much more fitting name.
You know what, actually, you hit nail there, because Quark was one of the Ferengis in Deep Space Nine, and his name would have been so much cooler if he was called Chromon. So if he was never Quark, yeah, like having a Ferengi called Chromon would have been better. Otangelo, what do you think?
I don't have an answer to that question. I'm not so versed in physics, so I pass the word.
Over to you, Creaky.
Next one's from Round Thinking. It's a question for both of you. Why you all insist on either or regarding Abiogenesis and intelligent design, and not on a combined option where the creator, if exists, sets up the natural laws and lets everything else run by itself?
Otangelo can go first on this one if he wants to.
Well, because as I explained during our debate, in order to have minimal self replicating and free living cell, the complexity is far, far too big in order for unguided random events to be able to instantiate that kind of complexity. And that starts even with the basic building blocks of life. Science has no clue how the four basic building blocks could have emerged prebiotically randomly. And that starts already there. And to have the transition, if even that would be solved, that problem, the transition from prebiotic production of the basic building blocks to a fully assembled self-replicating cell, that is a huge gap, which science has absolutely no clue how that could have happened. And another big problem is that molecules, they do not have the urge to complexify by themselves. They devolve and they become asphalts. And there is a science paper from 2012 from Steve Benner, and he points it out very clearly. What has been observed is that molecules, they do not complexify, they devolve.
Leo?
So there's 2 points to this question that I'd like to make. Number one, the reason that I don't assume that a creator could be involved with natural processes is because it isn't. That there's nothing in any of the natural processes that we understand that indicates, implies, or otherwise evidences a creator. Number two, a creator has never been observed, detected, measured, examined, or verified in any way, shape, or form to be able to confidently say it has any effect on reality. I mean, we understand for the most part, you know, how stellar nucleosynthesis works. Nothing that we've ever developed in terms of understanding that has implied a creator. We just, it's not, even if one does exist, we don't need to infer it to understand the reality in which we exist. The second part is, it seemed that they were alluding to this idea that, well, the laws of nature could have been written by and set in motion by some creator. The laws of nature, and this is something that a lot of theistically minded individuals, an argument they try to make, and it's just flat out wrong, is that the laws of nature they think are some supervenient thing that exists independently of reality, that tells reality what to do. That is not at all the case, and it never has been. The laws of nature are descriptions of what reality inherently does on its own. So to give an example, general relativity doesn't tell space-time to curve in the presence of mass. It describes how space-time curves in the presence of math. Reality just does that of its own accord. General relativity isn't there saying, oh, there's mass there, space-time, you better start curving. That's not how it works. The laws of nature are not prescriptive. They do not prescribe structure and function to reality. They are descriptive. They describe the structure and the function that we observe in reality based on the general consistencies that we observe in reality.
Cool, both of you. I think there's one last question I've got on my screen. I've not refreshed yet. Theo Fungi did say, why has Leo only got 134 subs? And if you haven't subbed to Leo, I'll put his, and Tangelo, I'll put both links in the chat while they're answering this question. Yes. So it's to you, Tangelo, and it says, when you say intelligent design, do you mean intelligent design or do you mean God? For example, could it be some sort of computer simulation? Would that fulfill intelligent design?
Well, a computer simulation would be not conscious, I imagine. So that wouldn't be intelligent design. What I understand as intelligent design, an intelligent designer, a conscious, powerful being, which is intelligent and created the universe and everything in it.
Okay. I'm just putting your link in the description there for anyone who wants to click on it before we go. Because we're almost at that time.
Say really quick that, I mean, if anybody's interested in the things I talk about and the content that I have up on my channel, at least if you consider hitting that subscribe button, I'd greatly appreciate it.
Yeah, I've just put that link in there. So go on to both of them, hit that, and I'll certainly tweet you out. I do think I saw a couple of super chats, Creaky, as well.
Yeah, I was just going to say we got a couple of super chats. We've got €2 from the Snark. What? Only one super chat? Impossible. I couldn't agree more. How rude. Jonathan Finley, $4.99. Can we agree that we have evidence that DNA is created naturally through replication and codes and blueprints are created by humans?
What? So can you repeat that question?
Absolutely.
Again, please.
Can we agree that we have evidence that DNA is created naturally?
So that was the first part?
Yeah, and the second part is, can we also agree that codes and blueprints are created by humans?
Yeah, and obviously Otangelo has to answer for himself, and I'm sure that his answer will be different from mine. But yeah, of course, I would argue that DNA was developed naturally. I think that there are two potential pathways for how DNA could have developed out of RNA. I don't actually know all that much about it. I haven't. That's one question I haven't really asked any of the professionals that I know. I'd be actually very interested in asking them and hearing their answers. In terms of the codes and blueprints, yes, we do know that humans create those things. And this was something that, who was it? I can't remember who I asked, but I asked them a question about whether or not DNA was a code, and they said that the DNA, in terms of the actual physical molecule itself, is not a code, but the ways that we represent how that molecule interacts and how it can produce things is a code. What we call the genetic code is a code table that humans invented that in turn represents the molecule DNA and its fundamental structure and its interactions that it partakes in the natural world. So the genetic code was developed by an intelligence, namely humans. It's a separate code table that we invented that describes what DNA is and what it does. But the actual physical molecule itself is not that code. And that's why I brought up the point of confusing the map with the place, because I think that that's a good analogy for what I think a lot of creationists tend to do, is they confuse the map with the place. They're confusing the description of a thing with the thing itself.
Angelo, do you want to add anything to that?
Well, Leo has literally demonstrated that he doesn't understand what the genetic code is.
Oh, I do.
Well, no, you don't. You have just.
Well, you say I don't, but I do.
Can I speak, please? Can I speak, please? As I explained to you during our conversation, and it seems you didn't understand what I said, but when we finish our debate, you can look it up. The genetic code is the assignment of codons of triple nucleotides to amino acids. There are 61 codons and 3 stop signals, they in the total 64, which are assigned to 20 amino acids. And that assignment, that cipher, constitutes the genetic code. That is not something metaphorical, that is not something analogous, that is not something symbolical. That is a literal assignment, okay? That's the first thing. And secondly, the DNA molecule, it stores literally information in the sense that in the sequence of these codons, they are instructing how the amino acid sequence has to be polymerized. And that is absolutely essential in order to get proteins which are functional. Now, in regards of the other question, science has absolutely no answer in all these decades where they have made experiments to try to make the RNA in the laboratory. They don't know how that could be done. It is a huge problem. I have 2 videos at my YouTube channel, Intelligent Design Academy, where I outline all these problems. It is absolutely not solved. And of course, there is also a huge gap between the prebiotic synthesis of RNA and DNA, and then the transition to enzymatic synthesis. And cells, they use hugely complex metabolic networks and processes and assembly lines to make RNA. And the transition from RNA to DNA is absolutely fantastic, and it's hugely complex, and it uses RNR enzymes, ribonucleotide reductase enzymes, which are enormously complex. And to explain how this could have emerged prebiotically, this is absolutely in the realm of the impossible. And I say that in very clear words, it is impossible. Anyone that studies these enzymes will agree with me.
Okie dokie. So I think we'll be agreeing to disagree on that one. I think there were a couple more super chats.
Yeah,
you guys
$10
need like a bell or a buzzer you can hit that anytime either one of you or somebody else says agree to disagree, since that's the name of your channel, you can hit that buzzer.
I've got one. It's my bullshit button for when someone says something really bad. What do you think of that?
That's awesome.
That's pretty cool. That's clever.
I want one. $10 US from Christopher Shapley, everybody's favorite American veterinarian. Some love for the channel and great job, Leo. Jay Vers has become a channel member, and 2 squid from Jim Broughton. From Jim, if God had a name, what would it be?
I'm thinking Fred. I think Fred would be a really good name. Either that or Steve. No, just something simple.
As long as it's not Keith, I don't mind. No
Yeah,
offense
no,
to any
Keith.
Keiths
No, not
watching.
Keith. Terrible name.
Yeah,
Terrible.
exactly. Oh, sorry, Keith Milner. Thank you, guys.
Yes.
Just makes me wish I could have followed along a little bit more with what was being said, but what do I know? I'm just here to make the place look pretty. Katz, have you got anything to say before you go?
Yeah, just want to say thanks to both of you. You know, it's I really enjoyed that. I'd have either of you back anytime. If you want to come back on, you're more than welcome. So thank you for giving us your time. I really appreciate that. We can't obviously do the show without people like you willing to step up. And I really enjoyed it. So thanks to both of you for all the work you put in. You know, preparing your openings, preparing your PowerPoint as well, Los Angeles. So thank you very much.
I did want to say really quick, if you ever get a hold of that guy that wants to debate on the electric universe, just let me know, because I was doing a bit of research on that, and that's something I'd actually like to debate, because it's a little quacky.
Well, I think, I'll be honest. We did mention that last time, and then I forgot to email the guy. So that's a good reminder. I will email him after the show's finished and see if I can set that up. But I think I've run out of things to say.
Yeah, me too.
So, right. Well, do you want, Angelo, do you want to have the last word? Do you want to say goodbye and we'll close the stream?
Yes, thank you very much for the opportunity to be at your channel. As I said previously, if you have someone that is interested to debate evolution with me, then I'm interested in that. And I enjoyed the time here. And thank you, Leo.
Thank you, Otangelo. I think we had a pretty good discussion. Otangelo he's a reasonable interlocutor. I like having discussions with him because he doesn't do what a lot of others do. But I also wanted to say really quick before we go, if you liked this debate, this discussion, if you like the channel, if you like what Creaky and Katz here are doing, then consider hitting their subscribe button, because I'm sure they've got a lot more content to come.
Oh, legend. Well, and both of yours in the chat. I think Crafty Keeler's just put your channels in the chat there now, so anyone can track you both down. And I'm sure this isn't the last time we'll all be speaking. So on that note, I shall say see you later.